In lesson 7.2, we're going to be talking about simplifying algebraic expressions. Again, focusing on that essential question of why algebraic rules are useful. It's just like any other thing in the world, football or cooking or whatever you're deciding to do. There are rules involved. Now, there's always some deviations from the rules, but in this case, we're talking about some fundamental algebraic rules that we can use and apply to problem-solving situations. So in this lesson, you're going to identify parts of an algebraic expression, and then you're going to use that distributive property we talked about in 7.1 to simplify algebraic expressions. So in this lesson, we have a couple, actually more than a couple of vocabulary words: term, coefficient, like terms, constant, simplest form, and simplifying the expression. All of those can be found here on page 299. Okay. Remember that terms are separated by addition and subtraction signs. And so in this example here, we have 1, 2, 3, 4 terms. Okay. Anytime that there is a number in front of a variable like this right here, the coefficient is the number out front. In this case, it's a 3. Even though this x is hanging out by itself, there is a coefficient there. We don't normally write the 1, but the coefficient is 1. And we have in these algebraic expressions what we call like terms. So we're going to put things together with the things that they're like. So in this case, 3x and 1x is the same thing as 4x. We also have a 7 and a 2. Both of those are constants, and we can simplify that to be 9. Okay, just like you wouldn't say, I'm 7 plus 2 years old. You wouldn't say that. You'd say, I'm 9 years old. Okay, so let's take a look at some examples of using those vocabulary words in context. Okay, so in example 1, all we're doing is identifying the like terms. Okay, so it's very easy here that we can see there are two like terms, 3x and 4x. Okay, and in B we have 5x and we have 7x, but we also have 3 and 4. Okay, so for got it, example 1 on page 299, the like terms in the expression. Go ahead and pause the video and try to identify those on your own, and then press play when you're ready to see the answer. The answer is negative 4x and 2x, and then 2y and 3y. Pretty straightforward there on identifying like terms. On page 300, we have example 2 at the top of the page. In example 2, it says to identify the terms, the like terms, the coefficients, and the constants. Okay, so there's lots of vocabulary there. You might need to flip back to your vocabulary from the previous page, or just look at the notes that you wrote down for those vocabulary words. And what we have here on number 2 is to identify the terms. Okay, so the terms are 3n, 5m, negative 6m, and 2. Okay, the like terms would be the 5m and the negative 6m. The next thing is the coefficients. The coefficients are 3 in front of the n, 5 in front of the m, negative 6 in front of the second m, and then this would not be considered a coefficient. It's a constant. So the last part, the constant, is 2. If you want to abbreviate that, just put down terms equals this, like terms equals that, coefficients equals that, and then constants equals that. Just another way to write those out. So moving on to example 3, we're going to take those algebraic expressions and not just identify the parts, but we're going to simplify if we can. And we're going to simplify by doing something called combining like terms. Okay, so you have 2 examples here, actually 3 examples worked out. And what we have is the application of the commutative property and the distributive property. Okay, we have some other applications here: definition of subtraction, the identity property, the commutative property, and the distributive property. So make sure you take a second to look through those examples before jumping right to the got it problems. Okay, These ones up here, I won't make you write out every single step, but just know that when you get into geometry, there is something called proofs, and you will have to write out these steps step by step and identify what theorem or what property you're using. So I won't make you do it now, but just know that that's something you will do in the future. So on 3A for got it, what I like to do is I like to circle my like terms or underline things just so I don't forget negative signs and positive signs. So in this case, notice that I put that negative sign and I circled it with the 3x. So I have 4x minus 3x, which is 1x. And we don't have to write 1x, we can just write down 1. And then left over is that constant, the 6, I can't do anything with. So the answer to number 3A is x plus 6. Okay? In 3B, I'm going to circle the 2m, and I'm going to circle negative 7m. Whether I say negative 7m or minus 7m, same thing. I am going to underline the 3 and the negative 4, or the minus 4. What's 2m take away 7m? You should be thinking negative 5m. And then we have 3 take away 4, which is minus 1. The answer to 3b is negative 5m minus 1. Notice on 3c we have parentheses, so we need to distribute. And since we don't know the value of p, all we can do is take that 4 to the q and make that 4q, and 4 to the 8p, don't forget to multiply, that's 32p. And then this plus p is by itself, okay? We're not going to distribute the 4 to that because it's not in the parentheses here. Now that we've distributed, we can combine like terms. So I have 32p plus 1 more p. That's a total of 33p. And then the 4q, there's no sign out front, but we assume that that's positive then, right? Because we don't go around writing plus signs in front of positive numbers. It's just assumed that it is. So 33p plus 4q is my final answer for 3C. Moving on to page 301, there is an example 4 where we have a story problem there, and we're going to be writing some expressions in simplest form. So go ahead and look through example 4. Remember that you can always check out the video tutor for another explanation of a problem similar to that. And then we're going to take a look at 4A. So Mato and Lola both collect stamps. Lola has 16 more stamps in her collection than Mato. Write an expression in simplest form that represents the total number in both collections. Okay, so in this case, we're going to always start with what x is going to be. X is going to be equal to Mato, M-A-T-O. You could also use a little m if you want to. M is for Mato. And then it says Mato and Lola collect stamps. Lola has 16 more than Mato. So 16 more than m would be 16 plus m. And who is 16 plus m? Well, that is Lola. Okay? Together, they have m for Mato plus Lola, 16 plus m, and we can simplify that by combining like terms. M plus m is 2m, and then that plus 16 just gets tagged on. Okay, so the final expression simplified would be 2m plus 16 for the total stamps that they both have. Okay, that was a little bit quick, but we'll do another example here. Derek has as many stamps as Mato. Okay, so if Derek has as many as Mato and Mato is m, would you also agree that m is equal to Derek too? Isn't m equal to m? And so if Mato had 3, Derek would have 3. If Mato had 10, Derek would have 10. If Derek and Mato have the same amount, then they're going to be the same variable. So now it says to write an expression for the total of all 3 collections. So we have Mato, m, plus Derek, which is another m, plus Lola, which is 16 plus m. Okay, and now we can combine like terms. We have an M, another M, and another M. So that's a total of 3M and then plus 16. Okay, you will do so much practicing of this concept of writing expressions and even writing equations by defining the variable. That's what we did here. We defined the variable. And you'll do lots of that in algebra and beyond. But right now, if you're a little bit not sure about that, just keep practicing. For this particular lesson, you have, of course, the online check. You have a worksheet with 15 problems to work out and then correct your worksheet and put the score at the top. You have a couple IXL lessons to practice, and then you also have an Ed puzzle that explains this process a little bit more. You do need to take notes on this Ed puzzle for this lesson, and again, it will give you a little bit more practice of combining like terms and simplifying algebraic expressions.